They are not coming.
When I show up right at the timer, there's a whole crowd of people waiting for me. But today I showed up 10 minutes early, 15 minutes early, and there's no one here.
Anyone send we didn't send a thing out either, a notification?
I started that out here.
Oh, did
It
you?
was a little bit late, but still, I didn't see it.
I mean, people know.
Yeah. I know Hector said he was interested in talking about the project today. I wonder where he is.
He was in the building.
Yeah. Who's Chris?
He was the one who said he's switching over to mechanical.
Is he?
Yeah, from pump side. I mean, I saw G and I think this guy here. You said Chris?
Yeah. I mean, they're in my class, so I know they're on campus today.
Yeah, Chris said he was coming. I don't know about G. G said he might be a little late. I think G usually shows up a few minutes late. What's up? Yeah, thanks for coming, man. We're like low today. And we had some cool stuff to check out, I guess. Maybe everyone.
What do you say we do?
I don't know, we can wait a little bit longer. I say we give it, I mean, if people don't start showing up, we give it at least 15 minutes.
Yeah, you got some beats or you got some tunes?
How did you do on the midterm?
I think I did pretty well.
Pretty
I mean,
well.
I think there's like a few mistakes I made.
For complex?
Yeah, the some
From my class.
I'm like watching what I see.
Yeah, yeah.
And
That's how I bet.
how did you guys feel about it? Was it like too hard?
No, I liked it.
Was it around the right difficulty?
If it was closed books, I would have struggled a lot. So-
Yeah. Well, I mean, yeah. I mean, I wrote it with the intention of it being, you know, open book, open notes.
Everything was very doable.
I got all mine coming up like next week. I haven't had any, and I feel like, yeah, I'm gonna have them all in 1 week.
Oh, yeah, it's pretty late if you're, because you know, this is week 9, so we're already past the halfway point. So if
Yeah.
you're having them next week, that's on the late side, I mean, it's, you know,
I'm doing my data structures next week.
interesting.
We're learning Tower of Hanoi.
The Tower of Hanoi, yeah. It's, talking about recursion then.
Yep.
Look, those guys are just hanging out there.
Our group.
Maybe they think they can't get in or something?
I mean, this door, I mean, it was
It's
open. It's
open.
Yeah, it's open now. It was closed when I came over.
The part that I struggle with is like the backtracking. Like, I still don't understand what values get passed when you start going recursively. You know what I mean? Like if it was like a for loop
Yeah.
and then like
So-
I gets incremented, I don't know, like
Yeah.
how can you tell which I is the value?
It's it depends on how it's defined, because, you know, you have your recursive function, it's whatever number you're passing in. And so it depends on, you know,
It's like, is it that, so you know how it's like, okay, there's this block, and then it calls the function again, so it's like a new block, right? It's like a new block.
yeah.
And so if there's like 3 blocks and then you go back, is the value from the 3rd block?
I see what you mean. No, it goes back to what it was.
So it's the 2nd block.
Yes. And so like you have some kind of function, call it on some, I'm abbreviating here, call it on some I, and you know, call it on, let's say I minus 1, something like that, right? So then this goes into, you know, well, if this is the function, then, you know, if you start with, let's say, the eraser. So let's say you, this is your recursive, this is a bad recursive function. If I is 0, return. There we go. So that's going to make I count down to 0, right? You
Right.
pass an I goes, if it's 0, you return, otherwise you go -1, then -1, then -1, so on.
Yeah.
So let's say first time through it's 5. Then you go in recursively, and the next time in it's 4. You go in recursively, the next time in it's 3, and so on, until you get back down to 0. When you return from 0, you know, you return, you're back up, I is 1 in this function call. Because each one of these is a different function call.
Right.
So I is 1 here, then when this one returns, you're back in the one where I was 2, and then you're back in the one where I was 3, and then you're back in the one where I was 4.
So if there was like a cout after the recursive function call, it would go from 1, 2, 3. It would like display 1, 2, 3, 4.
Yeah, so, yes, it would depend on where you have the cout.
Right, like after the.
Yeah, if you have the cout afterwards, then yeah, it'll go from 1, then return, you could do the 2, then return, do the 3, then return, do the 4, so it'll be 1, 2, 3, 4, 5. But if you have it before the recursive function call, you'll print 5, then go in, and then 4, then go in, then 3, then go in, then 2, then go in, then 1, then go in, and then do nothing on your way back out.
Okay, I see.
So that's actually kind of an important concept when it comes to like tree algorithms, when you're working with tree data structures, because you sometimes go through them recursively, and depending on where you put your actual operation before or after the recursive call, depends on whether you perform the function top down or bottom up.
Does a merge sort count as a tree?
Not necessarily. I mean, it's recursive. But I mean, if you draw out like the merge sort algorithm executing, it looks like a tree.
Yeah.
But it's not a tree algorithm.
Okay.
Like a tree
I haven't
is,
learned tree algorithm.
yeah, trees are basically like graphs that we talked about here. They're a type of structure.
Okay.
Actually, a tree is a type of graph. It's just a graph that only goes, only expands downward. So you can think of this like a graph, but
Better
this
late than
is a
never.
tree. Susan, that's not a tree. Trees have to only expand downward. So, So, yeah, if you were to like notate out what's happening in merge sort, it would look like a tree, like it grows bigger as it goes down, but it's not actually a tree, because trees are a specific thing. But yeah.
Good to know. That's helpful. Maybe we just do artists on this.
I mean, yeah, recursion's interesting. Recursion is such a hard idea to wrap your head around.
It is.
And I always found it so, like,
It seems useless.
it's not though. It's
Yeah.
so useful.
But I can't think of like
Well,
real world application.
well, if you need to, favorite this in your brain. Real world application of recursion, merge sort. Immediately, that's like super fast. Merge sort is so stupidly fast. And it's honestly not that hard compared to other bizarre sort algorithms.
Yeah.
So Also, you haven't gotten there, but tree algorithms, it can be useful to do recursion with trees. But, yeah, it doesn't seem useful. It's always amazing how you can do so much and such powerful stuff, and then you get down to it and the code is like 5 lines long.
Yeah, because when you're backtracking, you're doing all kinds of
Exactly. You're doing so much work, like the code is recursively calling itself and doing so much that way, but the actual function you have written in your program is nothing. It's like 5 lines of code. It's like 1 line base case, 1 line recursive case, maybe 1 or 2 lines actual operation. So it's like.
Are there like nested recursion calls?
I mean, theoretically. You have to be very careful with recursion because, first of all, it'll eat up your computer's memory like that. Because we haven't gotten here to pretend yet, but every recursion call is creating more and more memory. Like,
It's using the stack, right?
exactly.
It is using the stack.
You're using the stack. So every time you call, you're using more and more of the stack. And with recursion, recursion uses more of the stack for each function call than we've seen with our existing procedures. So you're adding a lot to the stack each time. And with recursion, you will add hundreds of calls. In any real problem, you'll add hundreds of recursive calls in an instant. So memory just fills instantaneously. Also, depending on the complexity of your recursive problem, like similarly to how, oh, it's such a complicated algorithm, but it looks so simple on paper, or in the code, there's a similar issue where, oh, it's such a simple algorithm, if I have it run on, let's say, 26 times, it'll be done in an instant. And like the Tower of Hanoi, I think the Tower of Hanoi on like 26 or 27 or some number in that range, if you start it now, it won't finish even after the end of the universe.
Yeah.
It's like recursion problems get so, the efficiency is so low. Tower of Hanoi is like a factorial of efficiency. I'm forgetting the term. It's got a factorial complexity, that's the word. And so it's like, every number you go higher, it's bigger than exponential. You can't call it exponential because exponential is actually less than what it is. Yeah. Understandable. Talk about recursion nonsense. We're here for programming club. Or at least some of us are here for programming club. Well, I guess we can.
I'm here for recursion nonsense.
I do have more on the map stuff I can show at some point.
Yep.
We were planning on it. I mean, we were going to start like a half an hour to an hour and talk about. They wanted to show off what they did during the hackathon.
Oh, sure.
And then we were going to work on the project, but people aren't here.
Yeah.
Yeah, I might be a bad judge.
So maybe we can talk about what you showed off at the hackathon, and if not enough, by that point, not enough people are here to work on the project, maybe we can do like a quick leak code something or other.
Oh, that would be cool. I'm down with that.
I've got some samples that I've been collecting for my classes. So,
And then if a lot of people show up next week, I'm hoping you guys are okay with us quickly presenting again what we did, just for everyone.
oh, speaking of next week, I haven't brought this up with the officers yet. Next week is the week where this room is reserved at our normal time, so we'll be in 107. I'll mention this a few more times. So next week only, 107. Lower the screen. True.
That's right across the way though, right?
Oh yeah, I think it's just right across the hall. Let me just double check that.
Also, hopefully starting this week, I'm hoping, but no promises because I have midterms. But
It's one of the rooms that's just right there, just across the hall.
coming soon, I'll start sharing the agendas before, like to everyone before the meetings, just so people can check it out and then we can get more interested. But today's, I guess, a quick agenda. We're just gonna go over what we did at Hornet Hacks over the weekend. We have 2 teams here. Lynn, are you good to present?
Yeah, I can do something for sure.
Okay.
I don't have that much.
And then afterwards, we were gonna work on the project, but seeing that there's not that many people here today, we'll freestyle it.
Pretty stuff.
But yeah, some upcoming events. Berkeley has their CalHacks tomorrow. I don't know if any of you guys are joining. I wasn't able to. But other than that, we do have the Halloween celebration that the student government is putting together October 30th, so next week. It's going to be 9 a.m. to 3 p.m. at the quad. We are tabling for that. I don't know if you guys have any ideas or if you guys want to do anything, but if not, then we're just going to be tabling. Other than that, De-Stress Fest, which is the week before finals for fall, it's going to be December 8th to 11th. We're planning on hosting a LAN party and hopefully fundraising some funds because pizza is running through all our money. So one of my ideas was to have like a competition style buy-ins for like maybe Mario Kart or like Super Smash. You know, like you can buy $5 or something, and then if you guys win, you guys get part of the pool, and then we'll stash the rest. But yeah, let me know if you guys have any more ideas. Other than that, are we allowed to do that? Is that like legal?
We're gonna have to double check that, I don't know.
Okay. Pending.
For the LAN party, like, what are you guys thinking? Because we talked about that, but I was like,
Very brief.
just like a console or something, or someone have a console they can bring? Or?
If you're talking older school games, depending on how people feel about it, but just like spin up, bring a PC and do like an emulation machine.
That'd be cool.
And you can get people, if they have any, like I have, like Mario Kart and Smash Brothers, I have those like emulated, and you can get adapters to put GameCube controllers on the computer that way too.
I think the problem we run into though is well, LAN parties can get pretty expensive. They're like a big event themselves, but we don't have someone there at all times to like watch over the stuff. And then like, if we just leave something on the table, like where people could just, because it's Distress Fest, right? Usually it's like on some of the campus somewhere where people can do something. So,
Well, I think we're only going to be, depending on availability, we're only going to be tabling for like a specific section of the time. So
I mean, do you
whenever-
guys have consoles where you would be okay if they got vandalized or anything of that nature, you know?
Wait, what's the LAN
LAN party is like when people
Bring your computers, I think, is a little harder to do in our,
Well, like historically speaking, it's like you bring your computers and then everyone connects and plays
party?
games.
Like rather than look over
Yeah.
Yeah.
I mean, it's, the concept is a little outdated. You can play games with people without having to bring your machines and connect with cables anymore. But that's where the idea came from. It's like, everyone bring your machines and we'll all hook up cables to connect and we'll all play games together. But-
Playing old school Halo and hosting a local Halo server.
Yeah,
Yep.
yeah. I remember doing that in high school, but even by college, everything's wireless now. So it's like the concept of a LAN party's kind of died down.
But this would be like, so if we have this, so are we like out on like the campus, or would we have a room?
no, yeah, we'd have to get a room or something.
Yeah.
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 I mean, the good part is the good thing it's quite a ways away, so we still
Yeah.
have like
Yeah.
plenty of time.
I mean, if we can get just like a game, some party game, Mario Kart, Mario Party, whatever you guys feel, maybe Halo, like just a game, a screen, 4 controllers, and say, we're playing a match, and then everyone rotates out with the line that's behind them.
Yeah.
Right? That could be a nice addition to De-Stress Fest.
Yeah, I agree.
I mean, we don't need to do like a full like organization. It's just we're gonna be one table at this thing. And I know this is the place where they bring like the therapy dogs. So you
Yeah,
just
yeah.
go and pet dogs for an hour between finals or before finals. So just something we can add to that if we want to. That's what we were thinking about. And maybe not even each day, 'cause, you know, they're doing that like the whole week. Maybe only 1 day or 2 days. Whenever we have people there to table, because definitely what Lynn's saying is right. We're not. We won't just leave something unattended. We'll have somebody there watching, monitoring, making sure that the lines, that people swap out after their turn, that kind of thing.
So we need a screen though too.
That's the
Outs.
catch. Oh, yeah, that's the catch. Is we would need a screen and we would need something to play games on, computer console, whatever it is. And
I think those rooms in the cafe have a screen, one of them,
the screen will hopefully not be the hard part.
with the projector.
But either way, we've been throwing around this idea since the beginning of the semester.
I mean, would you guys think the cafe is a good area to do that? Have you been in those rooms? There's like the cafe and there's those two rooms off to the side.
I didn't know.
I didn't know that. I think we need to ask, like, the board, the K board, how this event's gonna go down. Is it something where we can collaborate by just doing something here in our club room? Or to be a part of De-Stress Fest, are they gonna give us a table in the quad and that's the space we have to work with?
I can ask.
Yeah,
I
that's what we need to
think
know.
from when I did it last year, they go on during the day. So it's during, it's mostly during early hours to the afternoon, like right about now it'll probably be shutting down. And usually they have some of them are in the lower parts of the student government building below, where they do the award ceremonies and whatever that space is. And then I guess some of them have like the yoga. I don't know where they were doing the yoga at, but then the dogs are just hanging out right in the quad.
Okay.
So it's like you could just like move around the campus, different areas, and they just have the signs with the location and time. You kind of just like stroll over there.
I mean, in that case, we might consider planning something just for our club meeting that week
Yeah.
and inviting the campus, right? We could do something along those lines.
Yeah.
Because then we would have this space, we'd have to still bring the tech in whatever we need, but we can then use this space at our normal time, and that could be our last meeting of the semester.
You showed up? Nice.
All right, but that's just something to think about. As always, DMP with any idea. We're just gonna do a quick showcase of what we worked on over Hornet Hacks. So I teamed up with Makai, Anthony, who's not here, Elliot, who's not here, and Lo, and we.
No, he's not here either.
Yeah, none of them are here. We worked on the healthcare category, which was one of the most populated categories for some reason. So we were against 8 other people. We didn't end up winning anything, but I was still very proud of our idea and our execution. So we created an app called Poolside, and basically what it is a drown prevention app geared specifically towards toddlers. And some slides. We ended up training we tried to train our own model. So we used YOLO V8 as our base model, and then RoboFlow, which is like a data center for like a website that has like a bunch of pictures, and then you can download it and then train the model that way. So we were training the model, or that was my part of the project, I guess, and it didn't work out, to be honest. We were trying to train it over 7,000 pictures, and then each iteration was you'd have the model would have to run over all 7,000 pictures 100 times over, and it just ended up being too much processing power, and then it would like crash my computer every time. But that was what we tried. We ended up, let's see, this is the technologies we used. We used Flask, React Native, WebSockets. That was all Anthony and Elliot. OpenCV is the computer vision, RoboFlow, YOLO V8. And then this is kind of how it works. So this is our front end. This was the home screen for the app. And then this was our mock-up right here. And right here you type in, I I guess you connect to the security camera, and it's supposed to send an alert to your phone whenever the toddler gets too close to the pool. But you can see here, like, the model is kind of hallucinating, like between toddler and non-toddler, and that's just our, we weren't able to train them as the model. But yeah, that's everyone who worked on it, and
Nice.
yeah.
I will say that John Kai and Daniel did do a good job, like presenting too.
Thank you.
They were able to like answer questions. I thought pretty good.
Man.
And he was asking hard questions.
Something about that, they only gave us 2 minutes, okay, 4 minutes to present and then 2 minutes for questions. So the judges would ask like questions and then you had 2 minutes to answer it. And regardless of whether you were like mid-answering question or not, or something, if your time ran out, they cut you off and then the next person went up. So like, yeah.
But did you design this around the 4-minute presentation? Like, what did you know about this?
To be honest, we weren't ready for the presentation at all. Like, we focused way too much on the back end, and we made this presentation in like 30 minutes. It ended up being like a lot like a pitch deck, so I think that contributed to a lot of why we didn't place higher. But yeah.
What? Honestly, you definitely carried when it came to designing the presentation slide.
What's
And
that?
then, when you designed all the slides.
I used to template.
Yeah.
Yeah.
It was a template actually was a lot better than what we had going on.
Yeah.
And then, what? I remember the feedback that we got was just, we didn't explain better on how, like it shows in our slides from like taking photos of them and how marketable it is.
Yeah, another big thing that we lagged on was like the entrepreneurial side of this whole thing. I mean, it was Carlson Center Innovation Entrepreneurship. And we kind of categorized it as a nonprofit open source, so I think that was kind of my bad as well. But yeah, like we were answering one of the, I thought was a really important question to answer to the judge and they cut us off, so.
Yeah, I don't think I would have went nonprofit with this project.
Yeah.
But
Like, you can come up?
sure. It's my turn.
You have an SEC winner though.
So, oh yeah, you guys are the winners in my book. I also have a document I made for Nathaniel for some budget stuff going on campus. Sorry, that's what I was working on with it. So we did pop hair. Pull up the page deck for you. We had a pretty good, the guys showed up, they had a pretty good Google Drive already set up with a bunch of cool documentation in here. All kinds of API recommendations and stuff. All kinds of stuff over here. our pitch deck, paw pair. We kind of made it with like Expo here. Our GitHub's right here if you want to check it out. Pretty gnarly, like what some of these tools can do, I think. Because on day one, these guys were working with, Bolt. And Bolt costs money to use as a tool. And I just was like on the back end trying to figure out, read through Expo documents, kind of got my laptop ready for using Expo since I've never worked with it before. And I was able to like get, the basic Expo up and running. And I have started working with the Pet Finder API and some pretty decent documentation here on it. So Pet Finder is this service that's powered by Purina now. I think they got absorbed by Purina, and it just links to local shelters where you can adopt dogs. So you can see how you can see all their info and stuff, right? And then they created an API which lets other people create their own projects and kind of utilize their backend, right? Let's play the video. So this is kind of what Bolt puts out for you real quick. All dummy data, obviously, but pretty cool, I'm not gonna lie. This is kind of like what we had Bolt working with. So AWS, Expo, Node, Postgres. Let's see where the video go. So this is kind of what Bolt puts out. Pretty legit. No sound. This is on an iPhone. This is recorded on an iPhone. So obviously you have all the dummy data. Most of it's set up, right? You just gotta get the Pet Finder API integrated, and that's kind of what I was working on. So, but I spent day one just pretty much reading about Expo because I've never worked with it. So I got Expo installed, got it launched and ready for your front end design stuff. And then I was like, well, I need to do the API, and then I started trying to read about Flask and stuff because I wasn't sure which kind of back-end stuff we were going to use. So a lot of day one for me was like just hang out on dogs and trying to figure out what I was going to do or how I could participate. So it's kind of just hanging around here, and definitely a lot of like Copilot helping me out a lot, not gonna lie. But this is kind of like where I ended up with. So I don't have it up and running right now, but you just click fetch all dogs, and it would dump all your data. So it's pretty simple. I was like, man, I do not want to try and figure out Expo's file system. Because I was like, there's just too much stuff here. I'm barely that good with React, and Expo adds a whole other layer, and you have to learn about all their cloud features and stuff, because mostly what they sell is that step to take it from a development app into a production app. And that's their whole service model. You go with Expo, you pay them a few bucks and they put it on the market for you, right? Automatically. And so a lot of their stuff is integrated. It's kind of like you're reading through docs, all of a sudden they're like, oh yeah, you gotta use our cloud feature or whatever. So I just went into HTML and got a Node server up and running. been like looking into this stuff and kind of seeing how it's working so I can learn more about this stuff. And for the HTML document, kind of got just some JavaScript here. This is kind of what I was building the tool out a little bit more actually. Just messing around because I wanted to also learn about CSVs, and a lot of it's already integrated within JavaScript. So that's kind of out of that so I can look at those features and studying for future projects and integrating it more from the ground up. But yeah, so I just have a CSV table, and then obviously we get the API results. It's not very clear what results we're getting, but maybe we can fix that. And I have an error log for logging, but you can see like it's not going to work because I don't have the Node.js running. But see how, oh boom, I can preview the CSV in a table. And then if I wanted to, you can export it and stuff. Some of those features are in the functions over here. So yeah, obviously I got some studying to do, but this is like what I hope to be able to do day one at Hackathon, and definitely getting more getting more knowledge on Expo's file system and being able to just be in there real quick and know where the specific functions are located in their file structure and stuff like that. But yeah, so that's what I was working on while those guys were doing their stuff. Pretty much, that's about it. I mean, a lot of digging through documents here, Node, and Graph. I don't know what I was doing. Just trying to figure out, because we had no software engineer. So I was like, well, we got to get the API working somewhat, because that's like the whole deal of the app. Yeah, any questions? Cool. I think I got some stuff here too, like pictures and stuff. Some pictures if you guys want to take a look. This is my team. So that's Jeff and that's Scott. Of course, there's me. We got some winners. Here's Malachi with the guys.
Did you see the story?
That's right, when they were like, oh, you're taking our picture. I'm like, yeah, it's just yeah, it was totally fun though. Like, I learned a lot. I've been like learning new hotkeys and shortcuts and just being able to work VS Code like a lot more faster. Using like tabs and all kinds of stuff like that. And obviously I got some more studying to do with the JavaScript stuff. But it was definitely fun. And then I have all these videos. If y'all want to look, it's in poolside. You guys can but yeah, that's pretty much how it was. So we just did 2 days of hackathon, and then day 3 was just grubbing, chilling. It was fun. I had a total blast, and it was all like, you know, college students. Is that you guys right there, huh?
I'm here and then maybe as you get poolside.
Guys.
Someone else is there next.
Alright, so yeah, that's Cameron. If you haven't met him, he's a really cool guy. He's super helpful and definitely if you're interested in like Sac State stuff, he's a cool guy to talk to. Did you want to show yourself off too?
I can't, yeah.
I think we have plenty of time. We didn't really plan anything. No one's really here. So. I just after the video, if you want to come up. You don't want to show your deck? Hold on. I want to see Daniel like mumble there. Oh look, he's got the mic. What is he on the first slide? Good job.
Especially for residential values. Our solution is a specialized
So yeah, if you guys decide to do hackathons, this is what you can look forward to. Super fun while you're there. Obviously, a little less exciting to watch from the crowd, but it's just like food. We're learning. Everyone's creative ideas flowing and all kinds of stuff like that, right? Boom. Save some dogs, yeah. Yeah, I thought it was really cool. Both our projects were like save animals or save kids.
Oh, yeah. Well, no, they were using it earlier.
How many people have taken more than just the intro to computer science class? Or the intro to design? How many are like well within their, for those who computer science, their program? Couple hands, I saw.
I have it.
How many people are math people?
That's me.
Okay. I I'm not either of those. I'm literally only taking like my first computer science, so bear with me because I'm not going to claim that everything I have is fancy. But, so we've talked about we have trying to determine distances between points for our campus map. And we've toyed around with a couple different ideas on how to get that. And the one I proposed last time was GPS coordinates. As you can see, I'm gonna see if I can move one of those windows. I've been walking around campus a lot. And I'm hitting a couple roadblocks, mostly on how to name some of these points. Like, do I just call them path A, path B? But I do have the entrances to several buildings marked with exits. This green path is actually the path I walked today, and so I've been looking at the campus map, adding points, and the next step obviously then is, okay, I have a list of all these GPS coordinates. How do I determine the distance between these points? Am I actually going out with measuring tape and measuring the distance between all these points I'm walking? Turns out I don't have to do that, there's a math formula for that. The Haversine formula, it's pretty easy and straightforward to say I can go and just walk like straight lines between all these points and measure it. The Earth is not a straight surface, it's a sphere. It's kind of a weird oblong sphere oval shape. So there's a formula for that. There's a formula to determine the distance between any 2 points on a sphere, specifically given their latitude and longitude. So, from my walk today, I have upped my very shoddy Python scripting with a calculator, basically given the distance between two sets of latitude and longitude, we can calculate that. And if I run that, I already printed at the bottom, spoiler, but this is my walk today, and it shows the distance to the last point as I keep walking along each point. So, you know, each of these however many, like, it's roughly picking up every 3 or 4 feet, sometimes as close as 2 feet, every single point along the way. 3,170 feet, 0.59 miles. It's an approximation, given the Earth is weird and not a perfect sphere. But this was my data pull for my walk today, 0.59 miles. And if you look over, this is literally Apple Health data. Distance is 0.58 miles. So a pretty solid approximation of how much distance between every point I'm walking. So now, with that, we can use those references and then get these points of like, here's the east entrance to Raleigh North, here's the student services entrance, Butterhill South entrance. I have many more entrances I need to label, but we have a rough formula for taking any two given GPS coordinates, latitude and longitude, and actually determining the distance between them. So that's a step closer. We obviously have to account for things like, you know, we can't necessarily have 2 points that are crossing over a building, as you mentioned before, but closer. So that's where at least I've been at so far in terms of data collection and point identification.
That's really cool, yeah.
I wonder how different the numbers would be if we assumed that it was all a flat surface. Because it's true that the Earth is a sphere, but I wonder if that matters, like, at all.
It probably doesn't.
For a distance just across campus.
It probably doesn't give the distance, but I was just like, I have the coordinates anyways.
Yeah.
So since I could just plug it into that formula, it gave me a rough approximation, and it's off by like point, like a 100th of a mile.
Yeah, I mean, it's probably, that's probably what it would be, is at most, if we assumed it was a flat surface, it'd probably be like,
so.
maybe an inch or two.
The distance formula that you showcased last week, would that work with?
So the one that I showed off was just kind of a mathematical, you know, I was just Pythagorean theorem.
Right.
It's just a basic mathematical distance between 2 points on a flat surface. So mine assumes flat surface, this one assumes curved surface. So,
I do not know any of the extensive math here. I'm not a math person, but.
so I mean, it's just a different formula for distances. I mean, it really just depends on, do we want to account for the curvature of the Earth in the distance? Which I think, like I said, I think if we would even see a difference, it would probably be like on the order of an inch. Like it's, because I mean, the campus, the curvature of the Earth does not play in to the distance across our campus very much, especially if you're only going like from one building to another, let alone across the whole campus. But I mean, it really doesn't make much of a difference because it's, you know, it's just the formula for finding the distance between 2 points. And really, as yours did, it's not even the distance between 2 points, it's the distance, well, it's the distance between 2 points, but we're getting many points along the way and calculating the distance incrementally. So it's not like we're getting the distance between door A to door B across campus. We're getting the distance from, you know, your GPS is tracking every second.
Yeah.
So the distance from here to here to here to here to here to here to here, and then just adding them up. So,
But since we have since the larger point, since we have a general formula that can take latitude and longitude specifically and calculate that, if we just build out our graph of points based on GPS coordinates. And other weird thing I kind of noticed too is the satellite imagery seems slightly offset from the actual paths I've been walking, because like I've had a few points where I would walk and like the satellite shows the sidewalks here and it actually shows I've been walking here. So I've kind of had to offset with basically a little amount of wiggle room, but it's negligible.
without specialized technology, GPS is actually off by a couple of feet if you just on your phone. Like I know, I forget where I first learned this, but like farmers who have their automated tractors drive down their field, they get like special pylons, probes, whatever they are, that improve the functionality of GPS to on the order of inches. So without that, GPS is more like on the order of feet. It's close enough, right? Especially like for cars. But so yeah, this one might be a little off, but at least according to the satellite view.
But once we actually hammer down
Close
on
enough.
the points we have and the coordinates we want to use, now we have a mathematical formula we can plug in, get the distances, and then expand from there, build out our graph and
Yeah, so if the graph were to contain, if the nodes each were to contain a GPS point, then just running it through that formula just gets us ourselves. So it's easy enough. Yeah.
He's not going to do it.
So, nice.
And we only have to name the nodes that, like the important ones, right?
I'm figuring so like, which begs the question, how many nodes do we want? Like, do we want to know at every single point intersection? How simplistic do we want it to be? Do we want to know at every single building entrance, or are we assuming, ballpark, get them to the building? How simplistic do we want?
Building entrance?
I mean, that's up to you guys. I mean,
How precise do you want it to be?
Yeah, there's no right answer here. I mean, if you guys wanted to be able to start at any given point on the map, you certainly could do that. Or if you just wanted a drop down of the door of Broad Hall North, door of Broad Hall South, door of Business Building, door of the Performing Arts Center. I mean, and then just have all the remaining nodes on the graph connecting those be just the connecting nodes, unnamed.
And so like, I was putting points kind of at like obvious intersections,
Yeah.
but, it's, do we want to do wiggle room for like, obviously, how many people cross the stacked parking lot coming in from the student parking lot type of thing, like ignoring this whole, probably not gonna go along the points of like the makerspace and everything, we're just gonna cross the parking lot.
Well, this does seem scalable, right? So, I mean, like, you can always just add more.
Yeah.
I'm assuming we just start with approximation for both of you, once we have to do it, where we go.
I think the real question
What's
is,
Oh,
once
yeah.
you have a
How
way
much,
of
like,
making
how much
your
have we
graph,
done so far?
you can add as many nodes as you want. You just say,
Just two.
what data does this node contain and what's it connected to? And it's just there. The real question is, how do you guys plan on storing the data for the graph? That's, if you're not familiar with graphs, that might be the bigger challenge.
Did you want to share what you shared?
I mean, I'll go again. It's free. It's free. Yeah, if you ever.
Oh, yeah. So, I was approached, because I've been, when I'm asked about what's the programming club doing, I just kind of give an overview of what's going on. I mentioned that during the meeting a week or two ago, and I was approached from, I forget who it was, but they said that there have been discussions at like the administrative level of getting an app like ARC has for our campus. And they were like, oh, and it somehow got through, from us to them, and it's like, oh, the programming club might be doing it themselves, like that would be more expedient than asking ARC to make it for us. So I haven't heard back from any of them, but there's definitely an interest in seeing this finished product on the campus level. So,
Well, there was at the
yeah,
hackathon,
so I
there
haven't,
was two projects that were like.
they haven't reached out to me yet, I don't know if they're planning on it.
Two people
But
submitted like stack
if we can get something
modifications.
that looks good, that
Website
we can
instead.
present, we can definitely advertise it to the whole campus. There's an interest for that. And potentially, get a building on the SCC website. Or if you choose to make it in the form of an app, get some advertisement across the SCC website, whatever it is. So,
I guess I have to wonder if it's
So
just,
it's done.
obviously
What?
we're geared towards, we want to build it.
No.
We want to build it.
yeah.
Is it worth reaching out to ARC though and being like, is there anything we can share with yours?
Certainly.
If that would be, if they have the bare bones like structure, we just give them the data points, they've already got something to build out the graph and whatnot.
Yeah.
distance.
So
I still think we should build it.
Oh, yeah, it definitely
Really
qualified to
interactive
build.
either.
I was hoping that they would reach out to me and say, hey, we want it to contain this feature and this feature and this feature, and then that would give us a lot of direction. Haven't heard about that, but if they do, I'll definitely bring it up immediately. But, yeah, so we're gonna wanna make this look polished. It looks good, I like the GPS.
I think, yeah, you did a ton of hard work, you man, I think it's cool.
We'll just need to get more people out there to get all the little crisscrossy paths, because, if we, that the quad area has so many crisscrossing sidewalks, and if we don't accurately cross them all, then, oh yeah, if we don't accurately have paths crossing them all, I mean, you already got most of them right there, then can we really say that it finds the fastest path?
I think personally what we can do, or what my recommendation would be is whoever wants to be a part of the data collection, just like if we do end up, which I think this is a great way of doing this, but if we end up doing this, we can just start plotting like
I literally had no, like, I literally went home and I was like,
how we walk the process. So if we're walking from the
What
street,
do you do this weekend?
parking lot to
This week?
the run home.
We can.
Yeah, it's,
Yeah,
I was
we're
thinking
talking
some of
about
this,
like you said.
to try and get relatively precise but not have to go everywhere,
I mean,
like when I do entrances specifically. There's a waypoint feature.
I'm supposed to be doing that RTS
So
stuff.
right at the
What are you
entrance,
doing?
mark, here's the coordinates, I'm right here. Okay, keep that static and then put it in manual. So that way I don't necessarily have to walk everywhere, but I can get all of the major points.
The hackathons like that.
And mostly just the walking to this point is just kind of verifying distance and that's like a fallback. But I can mark all the major points separately.
Just like a successful business match.
Yeah, I passed
$100
this file
stamp
on the
down.
same particular.
Another question I would have is,
I did
so
say.
say we have a note on like one of the sheets.
I don't know what's
But
that
we
called.
need to know
What was that?
the pathway
Is
from
that called
the gym
shoes?
to
Obviously.
every single other like,
Type of shoes that.
building.
Well, you don't need to know the path. I mean, the
That's the
whole
guy
point
that
of
did
the program is that it will tell you the fastest path. You just need all the data points for all of the possible paths. So like, North Gym, it's like,
I know
okay,
the shoes.
where's the sidewalk go in this direction, that direction, that direction? It's like, and this, each node only needs to know the nodes that it's connected to. This node says, this entry says, I'm connected to that junction in the sidewalk, I'm connected to that junction in the sidewalk, I'm connected to that junction in the sidewalk.
There could be a possibility where where it would look at every single node, but it's not necessarily, because it's just trying to get to the node at the end of its, here's the
Exactly.
going point.
I mean, like I showed off with the Dijkstra algorithm, technically, when you run Dijkstra's algorithm, it looks at every single node on the graph. It doesn't just say, here's the fastest route from this point to this point. Technically, what it does, it says, here's the fastest route from this point to literally every other possible point you can go to. And then you just say, okay, tell me that one, now that you have the final result. Of course, that's not the most efficient. There are ways of making it more efficient, like starting the search at both ends and just finding out where they meet. That's actually that actually gets you the fastest path. But yeah, you don't need to mark out all the paths, you just need to mark out all the different ways you could go. So you say, okay, from here, where can I go? Well, I can go down the sidewalk that way, and so I'll put another waypoint here, and then I can go down the sidewalk that way, so I'll put another waypoint here. And that's all the entrance to that building needs to know, is I can go that way or I can go that way. And then at that junction, you say, okay, I can go that way, that way, that way. At this junction, that's how you build out your graph. It's just points with lines connecting them.
So the node only sees neighboring.
Each node only sees what's next to it. It has its own data internally, and it knows what it's connected to, and that's it. The whole point of the graph is that it's just a bunch of nodes all connected to each other. I mean, theoretically, it's also possible for graphs to have like separate sections where like technically there's two parts of the graph and none of the nodes connected in the middle. Of course, that's not true for real life. There's not like two halves of the campus that can't reach each other. But the whole idea of the graph is that it's just, it's just nodes and connections and that's it. Each node knows what other nodes it's connected to and that's it. Each connection knows what two nodes am I connecting and that's it. And the complexity comes from just having hundreds of points all connected to other points. And you don't need to know what the fastest way from one building to another is. In fact, it would be a waste of time to try and figure out what the fastest path from one building to another is. All you gotta do is gather all the data and run the algorithm, and it'll tell you what the fastest path is. It might not be the one you expected. You might be all like, okay, I think we might complete this, and you might put in your own like route, and it might tell you, go around the building the other way. It's actually a little bit faster. You're like, oh, I didn't know that. That's the whole idea. Cool.
Sweet.
I think, yeah, getting all these data points is big. I think, in addition to collecting more data, obviously we need all as many points as we can get, we're gonna have to start thinking about how we're actually gonna represent this model in the code. That's the next step is, some of you are gonna have to learn how to actually make a graph in the code, actually code a graph. Which,
Yeah, that's G.
Are any of you guys interested in that? Because I'll be working on it this week. At least. But
Where do you even start with that?
Wikipedia.
Oh, great.
I mean, or like if you have a
Wikipedia?
if you have a text
When did
book
teachers
like
start saying go to
40,
Wikipedia?
40, when AI got invented in its works. Yeah. So I mean, if you have a textbook for this stuff about graphs, go there instead. That's probably better. But like, the thing about graphs is that it's not like an array where it's like, oh, how do you make an array? Here's how you make an array. I made an array. With a graph, it's like, how do you make a graph? And Wikipedia will give you a list of, you could do it this way, or this way, or this way, or this way, or this way, and there's pros and cons to all of them. So you guys got to decide which one you got to do. It's like, do you want to do an adjacency list? Do you want to do object-oriented, where each node is an object, maybe each edge is also an object? Do you want to, there's no right or wrong way to it, you just got to figure out how to make it work. Throw a prototype that just has like 5 points. So you can get it to work for just like 5 points. Because in the thing I threw together for last time, my graph was really hacked together. I just used arrays and listed out, here's a list of all the possible nodes, and then here's a 2-dimensional array of all the possible connections. It's not that efficient, but it worked. So you have to really decide how you want to go about it. That's up to you guys. I'm happy to answer your questions, but I'm not going to code it for you because I know I can do it already.
Okay.
If you guys want me to just do it all myself, I'm happy to put my name on it and then have nobody else on it. But yeah, what are you going to ask?
How long do you think a good time frame would be
It depends on how busy people get in between this. I mean, how many hours a week you expect to work on this? And how much time do you think it would take to learn about graphs? I don't know. If you put in, if 5 to 10 people in this club put in 1 to 2 hours a week of work into it, you'll probably have something good looking in 4 or 5 weeks.
That's a lot of people.
I mean, that's only, again, 1 to 2 hours a week, that's like just the club meeting. So it's, I mean, the data.
Come on, G.
I mean, there's really only 2 big parts to it. The data and then putting the data, modeling the data in the code, and that's, well, no, the third part would be representing it, actually putting it on the screen with the map. Like, you're already getting the data, you have to figure out graphs, you got to figure out how to show it up on the screen. That's basically it. Like, I know we've talked a lot about Dijkstra's algorithm. Dijkstra's algorithm is like 10 lines of code, and it's on Wikipedia. It's like, it's not a secret, it's not a challenge. So that'll take 10 minutes to put into your code. The hard part is gathering the data, which, you know, we're halfway there. Figuring out how to model it with a graph. And then once you have the model, actually putting it up on the screen so that, you know, people can actually use it and it's not just abstract data.
Well, I have the GitHub open, so if you guys want to collaborate, please send me a DM over Discord. I'm gonna start working on the back end this week.
The graph.
Yeah.
Yeah. I don't think we've had anybody volunteer to like do the front end yet. Like the actual display the map with the data on it. That could certainly be something that people, if anybody's interested in that.
I would appreciate help. I don't want to try this project myself.
Yeah, come on, guys, step up.
There's a lot of regulars that aren't here today that think they might be interested.
But
Yeah, I kind of want to go back to ArcGIS a little bit.
to what?
ArcGIS, because they have a bunch of like educational stuff in there. I think. It's good for everyone.
So, yeah, so the, yeah, because I'll throw whatever down, yeah, okay.
What do we need for the front end? Just a map?
I mean,
I got you.
I mean, if we're gonna do JavaScript HTML way, then it's just
I'll figure out how to get a 3D map of.
a 3D map.
I got
It's a bird's eye view. I don't.
bird's eye of 3D.
I mean, you can go 3D to have the heights of the buildings, but
You get to walk around.
yeah, the Google Street View, go for it, man. The hard part's gonna be getting the
Later,
images.
Jared. Did you sign in?
I-
Yeah, I sent them.
Oh, you're the
We
man.
just use like the campus like official map image. Figure out an approximation of, okay, scale this size, where on the screen represents like this coordinate. Map that and then.
That's what yours
Not gonna
is.
do it.
Isn't it?
Yeah, I mean, yeah, we could just use the parking map that they have available.
What's the growth?
That's certainly one way to go about it.
What?
All you gotta do is put
What's
it on
the
your screen and
the
draw a
graph
line.
drawn in here? So they have something plotted
Yes,
on
please.
with the data points. That's your job.
You too.
No, you're just at. Come on. What are you working on?
What?
You're not working on anything right now, or what?
Homework.
What was that? We all are.
I finished homework. I just so relaxing.
What you got for us, King?
So at the hackathon, there was a company called Neural Lab, remember?
Oh, you get the neural stuff?
So they give us the free team software and everything.
Oh, you got a free software?
Yeah, they
What?
it's in
I
the
missed
Discord.
that.
No, it's in the Discord still.
Oh, it's in the Discord?
Yeah,
Oh, what, all right. Are you gonna show it? You demoing it?
yeah. I'm gonna use my
Take a free license?
yeah. So
Is it for lifetime or what?
I think so. I would assume so. I mean, I now have.
What? Do you think it's like in like 1 minute?
Oh, you got jokes today, do you? And we'll save the jokes for after you, after you get something on the projector.
So I can move my character around just using my hand signals.
Well, that's cool.
So there their software is actually really easy to use. You can take notes on it. That's weird. I've never seen that before.
From the night.
Yeah. No. Something else.
So basically, how their software works is that it uses your hand signals to actually emulate the actual keys on the keyboard
Oh.
or shortcuts. So basically, I have it set up so that
Oh, bro, he's cheating.
certain hand signals
You
are
mobbing on this game right now, dude? You can't even get it.
So you configured this with the signals you put in, like you, oh, okay, so this is pre-configured, okay.
Yeah, so they offer, so the software that they give already has the hand signals
Okay.
there.
There's some
And-
language.
Oh no, they just give me a software like how do I explain it? It's like essentially like Google Maps, like you don't know how it works behind the scenes, but you can just do it.
Black box, okay.
Sweet.
Yeah.
It's like Python.
Well, you're making hand signals based on keys, so is that not sign language? I'm not really familiar with that.
So basically, they used AI to train it on hand signals, and it can detect certain hand signals. And let me show you how to do it.
And so you're just using the like, these signals already mean these things, but you could probably go in and say, hey, take this signal that you recognize and change it to a different command,
Right.
if you want.
So here it is right here,
Air touch, okay.
What?
and when I move my hand, it shows the right hand,
Yeah.
and you can see the small like, red text if I can go inside where it says open palm, fist, thumb up, thumb side, thumb down.
Nice.
And basically, in the settings, you can change.
Yeah.
Oh,
okay.
Yeah, so you can change each one for a different action.
Right. So it's already predetermined on the what they offer. So but they all make it. Let's see. You can make it a custom keyboard shortcut, so I can make it Control Alt.
That's precise.
Okay, that would work. Oh, it's Control Alt.
CRC. No one was planning on going to CRC today, they just got an announcement they're on lockdown.
For what?
It doesn't say. We're on lockdown, lock doors, avoid windows, stay quiet.
Oh, yeah.
If not on campus, don't go.
Yeah, getting that now. But yeah, there's been a lot of incredible improvements in computers for tracking this. And this is one, if you've ever used any like VR headsets, that's what a lot of the cameras are doing for their hand tracking. They're emulating, trying to determine the skeletal structure for hand gestures and stuff.
Using joints, right?
Where they can, yeah, as far as I know.
I already knew it was impressive using stuff like VTubers, but this is like an actual visual representation of what it's picking up.
This is Neuralink or?
Yeah, this is what we're talking
Huh?
This is AirTouch. That's the name of the software.
But through the Neuralink?
No, I don't know.
It's just a webcam.
It's just through the webcam.
So when is it? They gave us stuff at the hackathon?
Yeah, it's on the Discord. So if you go to, it's in a specific channel called Neural Lab.
Oh yeah, Neuralink.
That's what the name is.
Neuralink.
So I can just control my whole entire screen. Some of the code behind the game. So yeah, so I just worked on that last night, trying to add it.
That's really cool.
Studies for this one?
So I'm planning on making an actual dedicated game, like a strategy game of some sort, using these hand signals. Because obviously this game is made for like keyboard and mouse.
Yeah.
Because how like how quick and precise all the movements are. But I'm thinking about making a strategy game where all the movements don't need to be so precise or happen as often. So yeah. The call from Los Rios, that's the CSC campus on lockdown. Why is the CSC campus on lockdown?
They just said they're on lockdown. They don't have a reason yet. Well, we're short on members to begin with, and a few people walk out. So we're a bit short for the remaining 40 minutes today.
Does anyone have a C-type charger that I can borrow real quick?
Who wants to do a leak code?
You so scared me because I was learning. I'm going to waste it.
Yeah, I'll start. We only got 40 minutes.
It takes 40 minutes.
Do you guys know Project Euler? It's basically a set, there's a problem sets.
Is that the website that like they have all the math
They-
problem, Matthew? I'm thinking of it.
Yeah, it's basically just a big set.
It's puzzles, right?
Yeah, well, they're programming problems, but they're kind of math sided. So here's the first one, probably the easiest one. List all the natural numbers for a that multiples of 3 or 5, we get these, the sum of that. So find the sum of all multiples of 3 or 5 and 4 to 1,000. You guys reckon we can do that? Probably. This one might be a little bit on the easy side. Yeah. This is a for loop with, I think this is one for loop with an if statement with modulo. I think that's it. Yeah, this one's not too hard. Maybe we'll find an interesting one.
Can you check the Fibonacci numbers?
Even Fibonacci numbers. So you guys know the Fibonacci numbers, right? It's just, you start with 1, 1, and then each number next is just the sum of the previous two. So 1 and 1 make 2, then 1 and 2 make 3, then 2 and 3 make 5, and so on. So consider the Fibonacci sequence whose numbers do not exceed 4 million. Find the sum of all the even numbered terms.
You can do basically like a similar thing, though, right? Just keep counting the sequence and then do modulo 2
Yeah.
to get it even.
This
And if it
one's
is,
also-
then add, and.
There's only one, I think, hiccup you might encounter on this one, is that it's asking for some pretty big numbers. I think if you just try using base, it won't work. You'd overthrow. You've got to use long. Yeah, this is also not too bad. Let me know if one speaks to you. I mean, this is page 1, some of the easier ones. I think the most recent ones are not 155, they're not really long. And so they get through all the easy ones, and then by page 3, you actually get some challenging ones.
Special Pythagorean triple.
Pythagorean triplet is numbers a, b, and c, for which a squared plus b squared equals c squared. There's exactly one where a plus b plus c is 1,000. It wants to find those numbers. So find an a plus b plus c. Sorry, find an a, b, and c where adding all three gets you 1,000, but also a squared plus b squared equals c squared. There's apparently only one. Did you write that program? Is this one fair difficulty?
No, I would say so. I'm trying to think, like, can you do it in your head? You're the math person, so you're, you know.
I couldn't name a square above. Let's see. I think, let's see. I know my time scale was at 12. So I think as soon as we go 13 squared, I'm screwed. Oh no, 16 squared is power 2, but that's it.
It seems like,
But actually, the actual code needed to solve this. It's just loops and just loops and arithmetic, loops, ifs, and arithmetic. Did you guys do this one?
it's like I can see like a potential way to do it, just like test it out.
I'll tell you right now, you can brute force it. Even this one, even though it seems like a lot, you can brute force it. Yeah. So the three numbers, A, B, and C that add up to 1,000. Try every number 1 to 1,000 for all three of those. And just make sure that it meets all three conditions. It sounds like a lot, but the computer will do it in an instant. So, now if you wanted to try and be smart about it, make an efficient algorithm, well, I don't know. But you could just brute force this one with loops and if statements. I'll bring it back up in a second. You guys can try out see if I can get the answer. I don't think this page actually shows the answer section.
Gee. Nothing this weekend, huh?
Huh?
Nothing? Dude, I went to the hackathon, I volunteered at like Camp Pollock. Got the green, what do you call it? The nursery, I guess. Is that what they call it for plants? A nursery, right?
Yeah.
Interesting. Yeah, I cleaned up some nursery for some native plants. Sale. Back at it. I got it, bud.
Unusual.
What's that?
Everything just like usual.
Just YouTube?
Usual.
YouTube?
Usual.
What's it, YouTube? Yeah. Hater. Are you gonna present something, you?
We were doing a problem, hold on. I was trying to get the answer so that I can confirm once people had it.
What's the problem? You're not doing it? Bro, I'm telling your parents, bro. They're like, geez, such a bad student. No studying.
The phone is very bad. The screen.
Back up, there we go.
No, What do you want, music or what? I don't believe that.
What are you hiding?
I don't have anything. What do you think I have on here?
I don't know.
Dark web Bitcoin license there? Did you see the AWS went down?
Oh, yeah, the canvas.
I bought, I've been on the market this week. Are you trading?
No. Don't have no money.
You're such a liar. You have the money, G. I'll send you the invite. Join my team of investors.
Fine.
Interesting. Let me see.
I don't think there's a way of doing it other than brute forcing it. The question is, can you, I mean, you could literally check every number, 1 to 1,000 for A, B, and C, and just try to find one that matches. But you don't have to check all of those. You could make it more efficient. Although value of efficiency is maybe not too useful because again, it's less than a second. Even if you do brute force it in the least efficient way possible, it's less than a second.
Wait, are you writing an algorithm for this?
Think about the code that does it. Write code that finds A, B, and C. This is a bad problem because it's.
I was trying to use my human calculator.
I mean, that's the thing is, you could try and use a real calculator. Oh, another alert. Oh, all clear it, CRC. Oh, that's good, that's good. Yeah, probably gonna get the notifications on your phones and emails in just a second.
That's
So, trying to find the A, B, and C, but they have to match the conditions listed up there. The ones that A, B, and C add up to 1,000, and also A squared plus B squared equals C squared. And also, A less than B less than C, don't forget that one. And that's just because they only want one specific order. Older CRC is all clear.
How do you do this in G? Help me out. What? You get the math genius over here.
Brute force it. Use loops.
We're doing this in great.
All you need is loops and if statements.
H squared plus B squared plus C
Loops.
squared.
Loops, if statements,
B.
basic arithmetic. And maybe.
Now, all this have to be true, right?
What programming languages do you guys default to? C++?
There's Python here.
Python? I'm in Java.
How do we
That's me.
I'm not.
Probably because I'm teaching a Java class, so I have it immediately available.
How do we start? Here we go, import G.
The opposite of import G4.
Yeah, D4 G. D4 G. We'll just say D4 G. Yep. Answer the question. where do we start? I imported you.
And then you deported.
G dot. G dot math. Well, I mean, how do you make all these equal? Income. G4G.
I don't wanna go to,
Dear President Xi Jinping, he is underperforming. Programming club. We recommend military service for 4 years. Hard labor.
Pero they're gonna pass before zero. That's
Why you wanna go to El Salvador?
No, I wanna go to El Salvador.
You know? The prison, is that what you're talking about? It's not that bad there.
Serious.
You'd be fine. What do you think they're gonna pick on you?
They say, like I say into, like a prison. In El Salvador. Prison.
I think you'd be fine. I mean, I don't know. I don't know what the next institutions are like, but I'm assuming it's bad, but still. Not that bad. I seen that prison. It was like new.
In El Salvador.
That one.
They have like a mega prison. in El
Yeah, it
Salvador.
was like a new mega one. Better learn how to speak Spanish.
You know, be treated like that. I don't want to do. I don't want treat it like this.
Gee, where do we start with this?
Hmm?
Where would you start?
Probably skip up.
Hypothetically. I'm lost.
You guys making headway?
I'm trying to. I'm fighting G's algorithm those. It's tough.
It says that there should only be one set of numbers, a single A, a single B, and a single C that make it work.
Sorry, yeah. Hookers?
Huh?
Hookers?
Yeah.
You're gonna have to.
Put away my English degree.
As Guinean